Right, in today's video, we're going to learn how to apply the concepts of remainder theorem. Alright, so before we go into details on what this remainder theorem is all about, there's several questions that we need to ask ourselves. The first one, why do we learn remainder theorem? The second one, what are the things to take note when we're applying the remainder theorem? And then finally, we will have some examples on applying the remainder theorem. Alright, so before we learn what remainder theorem is all about, let's solve these questions. So there are three parts of these questions. The first part is to divide 4x cubed minus 8x plus 1 by x minus 2. So to do that, we're going to use the concepts of long division. So if you have forgotten how to do long division, it would be good that you do a revisions on that. So basically, your 4x cubed minus 8x plus 1 is your dividend. All right, and then your x minus 2 is your divisor. All right. So I'm very quickly going to go through the steps again. Right, so what's the first step? First step is to take the first term of your dividend and then divide it by the first terms of your divisor. So 4x cubed divided by x will gives you 4x squared. Okay, once you get the first term, then the next step is to multiply the first term with both terms of your divisor. Alright, so that will end up getting a 4x cubed minus 4x squared times negative 2 will be negative 8x squared. Alright, so we have 4x cubed minus 4x cubed will give you 0. Negative 8x squared will give you 8x squared minus 8x. You can pull down the 1. Right, so you can repeat the steps, the same steps that we've done earlier on. Take your 8x squared, divide by x, and that will give you 8x, positive 8x. Then take positive 8x, multiply with both terms of your divisor, that will give you 8x squared minus 16x. And you will have 8x plus 1. So repeat the process. 8x divided by x will be positive 8. 8x minus 16. 1 minus 16 will give you 17. Right. So your remainder is 17. So we're going to write it down. Okay, and then right, we also express it in the form of your dividend equals to your divisor multiplied by the quotient. We already found your quotient to be 4x squared plus 8x plus 8 and plus your r, which is your remainder. R is a constant. Constant meaning it's just a number. So yeah, 17 is a number. So plus 17. Okay, so this is a rather long way of finding remainder, right? Using long division. Okay, so how can we actually simplify this process? How does this remainder theorem comes in place? Okay, right. If you were to observe this very carefully, right? This here very carefully, right? Okay, what we're going to do is that if you look at this guy here, this is your divisor, right? This one is your divisor. If I'm going to let my divisor equals to 0, what will you get for x? X will be equals to 2, right? Right. And then if I'm going to substitute, replace the x with this number 2, right? Let's see what happened. Huh? Let's see what happened. I'm going to substitute x equals to 2 into my 4x cubed into this guy. Okay? I'm going to substitute x equals to 2. So I would have 4 bracket 2 to the power of 3 minus 8 bracket 2 plus 1 gives you 2 minus 2, 2 minus 2. Right, then multiply with q bracket 2 plus my remainder r. Okay, and then if you were to work this out using your calculator, you would get 4 times 8 minus 16 plus 1 gives you 17. Right? And 2 minus 2 gives you 0. 0 times this one does not mean, okay, q bracket 2, q it's the quotient, it's in the form of a factor, in the form of a polynomial, like what we have here. All right, so q of 2 means you're going to substitute x equals to 2. This is what it means. It does not mean q times 2. It means that okay, it means that if I'm going to represent 4x squared plus ax plus 8sq bracket x, what q bracket 2 means, I'm just going to substitute my x with this number 2. And if you use your calculator to work it out, it means what you're getting will be 4 times 4 minus 16, plus 16 plus 8, give you 40, right? So this is what it means. But it doesn't matter here. It doesn't matter here. Okay, we don't need to evaluate q of bracket 2. I'm just trying to explain to you what q of bracket 2 means. Okay, it does not mean q times 2. It does not mean that. All right. Okay, so it doesn't matter here. What happened is that I want to show you that when I substitute x equals to 2, right, what happened is that I actually get rid of this portion here. Okay, because 2 minus 2 is 0, right? 0 times whatever will give you 0. So you have a 0 plus r, and therefore your r is equals to 17. Right. So can you see that what we have done here is an easier way of finding the remainder than having to use a long division. So this method that we've just demonstrated, right, is actually these things that we're going to learn later on called the remainder theorem. So we have actually here, this portion here, we have actually just applied the remainder theorem. Right, so what remainder theorem is all about, it's if you have a polynomial f of x, and if it's divided by a linear expression x minus a, then the remainder will be just f of a. Right, so we're going to do the proof. So we're going to let f of x equals to your linear divisor, which is x minus a. This will give us, and then multiply with the quotient, then plus your remainder, which I'm going to let it represent by the letter r. Right, so what I'm going to do is I'm going to substitute x equals to a. And what would I get? I will have f of a equals to a minus a times q of a plus r. And if I simplify further, can you see my r is just f of a, right? Which is what we have said earlier on, that the remainder will be f of a. Okay, so we have actually done the proof for the remainder theorem. So more in general, right, we can extend it to, sometimes in the linear expression may be in the format ax minus b, meaning it could be in the format of 2x plus 3. It's still a linear form. It's just that it can be 2x plus 3, or it can be just negative x minus 4, etc. So if that is the case, then the remainder will just be f of b minus 8. So how do you get that? You just simply let ax minus b equals to 0, and then you will have ax equals to b, and then if you make x the subject, you will have x equals to b over a. So you're just substituting for x equals to b over a. So therefore, the remainder will be f bracket b over a. Whereas for the earlier one, you are just letting x minus a equals to 0. So you're just substituting x to be a. Therefore, the remainder is f of a. Right, there are some important things to take note when you are using remainder theorem. Okay, first of all, remainder theorem only applies to polynomials. If you have forgotten what polynomials are all about, do refer to chapter 4 of your textbook. And also remainder theorem, you can only use it when your divisors is a linear form. Linear form means in the form of ax minus b, right, where a and b are constants, right? So the remainder theorem does not tell us what the quotient. It's unlike long division. When you do long division, you actually find quotient, find remainder, right? But when you are using remainder theorem, all right, basically you're just helping you to find remainder. That's all. All right, you can't actually know exactly what the quotient is. So what happens if your divisor is non-linear? Then does it mean that you cannot use remainder theorem? Yes, you can still apply remainder theorem. All you need to do is to factorize your non-linear divisor, okay, into linear factors, and then you can still find the remainder by using substitution. We'll be showing you some examples on how we can actually apply remainder theorem on non-linear divisors. Okay, so we're going to do some examples on how we can apply remainder theorem. So the first example is a very direct applications, just applying the remainder theorem. So you're given a polynomial. We're going to call it f of x. You can call it g of x or t of x, whatever letters that you fancy of, that's fanciful to you, doesn't matter. But usually we just use f of x lah. Okay, right. So remainder theorems. Remember what we learned earlier on, the remainder theorems. It says that if it's equals to your divisor times the quotient, then plus remainder, right? So if you were to let 2x plus 1 equals to 0, x will give you negative half, right? So your remainder will just be f of negative half. Right, so what we're going to do is just going to substitute x equals to negative half into your f of x, which will give you negative bracket negative half to the power of 3 plus 3 bracket negative half to the power of 2 minus 2 bracket negative half plus 4. And this, if you can use a calculator to work this out. Right, you will get 5 over 8 as the answer for the remainder. Okay, so let's look at part B. Right, we're going to apply remainder theorem. So f of x is equals to 3 minus 2x multiplied by quotient plus remainder. Okay, so we're going to let 3 minus 2x equals to 0. So negative 2x equals to negative 3. X will be negative 3 divided by negative 2 gives you 3 over 2. Right, so remainder theorem says that the remainder will just be f of 3 over 2. Right, so we're going to substitute x equals to 3 over 2 into our f of x, which is x cubed. So I'm going to substitute x, which is 3 over 2. So 3 over 2 cubed plus 3 bracket 3 over 2 squared minus 2 bracket 3 over 2 plus 4. And this, you can just use a calculator to help you work out the answer. and you get 11 1 over 8. Right, so this is a very straightforward examples on how you can apply the remainder theorem. Right, so we're going to do another example using remainder theorem. But in this example, the divisor given to you is a quadratic form, it's non-linear. And remember what we've learned earlier on, to apply remainder theorem, the divisor must be in the linear form. Right, so how do we go about overcoming it? Yes, to overcome it, we just have to factorize your non-linear divisor into linear factors. All right, so if you look at what you're given, your dividend, this is your dividend, right? If you look at what you're given, there are two unknowns there, P and Q. Right, so if you have two unknowns, basically you just need to have two equations. You need to generate two equations, and then you just solve these two equations simultaneously, and that's how you get the find the values for these two unknown. Right, so first thing first, we're going to write down write your dividend in the format equals to your divisor times a quotient plus a remainder. Remainder given to you, it's x plus x minus 5, so plus x minus 5 here. All right, so we're going to factorize your divisor, which will give you 3x plus 2, x minus 1. No, wrong. Which will give you 3x minus 2, x plus 1. Let's check again. Yeah, all right. Right, so we said that we need to generate two equations, right? So we have to work on these two linear factors. Right, so there are two linear factors. So I'm going to let the first linear factors equals to 0, which means I'm going to substitute x equals to 2/3. Okay, so if you recall, if you let 3x minus 2 equals to 0, then what happened? Right, it means that I will wipe out this thing. Right, I'll wipe out the thing, and then I will form my first equation. Okay, not to forget, I still have my remainder, which is x minus 5. So I'm going to substitute x to be 2/3, so it's 2/3 minus 5. Okay, you can use a calculator to help you work this guy out. That will give you 8 over 27. Oh, wait, let me verify it. Make sure it's correct, otherwise you will have to redo the whole thing to the power 4. Or 16 over 27. Oh, hang, luckily. Work out. Use a calculator to try again. Right, so that will give us 16 over 27. This will give me 8 over 27t. Alright, I'm going to simplify further. You would have 2/3 minus 5. Take away 16 over 27. Take away 4/3 plus 15. Right, let me do again. Wait, hang on. 2 over 3 to the power 4. 16 over 27. Okay, so that is 2/3 minus 5 minus 16 over 27 minus 4 third plus 15. Okay, you will get 236 over 27. All right, so I'm going to multiply by 27 throughout. That will give me 8p. 4 over 9 times 27 give me 12 q, and 236 over 27 times 27 will give me 236. I'm going to call this equation 1. All right, so I'm going to generate the second equation. So second equation is let the second linear factor equals to 0. That means I'm substituting for x equals to -1. Right, I'm going to make q the subject. That will be q equals to 8 plus p. Call this equation 2. Right, so I'm going to substitute 2 into 1 and see what I get. I will have 8p plus 12 times 8 plus p equals to 236. That will give me 8p plus 12 times 8. Give me 96. Plus 12p equals to 236. That will give me 20p equals to 236 minus 96. 140. And that give me p equals to 7. And then you can substitute p equals to 7 into equation 2. You have q equals to 8 plus 7 equals to 15. Right, so this is how we can find using remainder theorem, find the values for the unknowns p and q.